We're given this circuit. It looks pretty complicated, and we're asked to find the current in the ammeter just after the switch is closed. So with these problems that involve capacitors in circuits, usually they're asking for information the split second after you close the switch or at some long time later. So these capacitors are all initially uncharged, and the thing you want to think about is what is the voltage drop across these capacitors. So for a capacitor, Q is C delta V. So in this case, initially, Q is 0, and if the charge is 0, then that means the voltage across each capacitor is going to be 0. So these capacitors are like shorts. You could take them out and put a short in its place, a wire in its place, and it would behave the same way, at least for a very, very short time after the switch is closed. Maybe you can turn off the video and try it yourself now. So the circuit's going to look something like this. We're going to have a battery. This capacitor is going to short out the resistor, so no current is going to flow through that resistor if it can flow through a zero resistance path. Then we're going to hit the second resistor here. This capacitor is also a short. We get to that resistor, get to our ammeter. Over here, nothing goes through that resistor because it all goes through the zero resistance path. So our circuit looks something like this. We have a 75 ohm, a 50 ohm, a 15 ohm, and a 25 ohm resistor, and this is 100 volts. Okay, again, this first capacitor shorts out the resistor. There was a resistor there, but it's being shorted out. There's also a resistor over here, but it's being shorted out, and this path is like a short. So nothing happens there, and let's take a quick look at this circuit. I've got two resistors in parallel. So I've got a 50 thirds, which is what, 16.7 ohms. And I can redraw this circuit. Now I have 1, 2, 3 resistors in series, and so I get an equivalent circuit. (75) plus 16.7 plus 15 ohms is 106.7 ohms. And so using V equals IR, my current is 100 volts over 106.7 ohms, which is 0.938 amps.